Hi, in this short chapter, we're going to talk a little bit about delegates or callbacks and how you can use them to write more event-based code in Unreal. So first we'll explore a little bit about the delegate or callback. How is it used? Where is it used? Then we'll jump into the editor and just do a little simple example to show it in action. All right, so let's start with what is a delegate? A delegate or callback, a delegate is Unreal's version of wrapping a callback function with some capabilities around broadcasting and listening to events. So there are multiple delegates that the system is capable of producing. The typical ones are the single delegate, or a multicast delegate, or events, and dynamic objects. So the simplest way to think about a delegate is it is a callback function. So you're defining what you want to be called when certain things occur. It typically happens after some version of an asynchronous function. And we'll explain synchronous versus asynchronous in a minute. And there are many places throughout the game loop where the engine determines that it should broadcast certain activities, which can then be picked up by other classes and then processed further. So some simple examples are on begin play is actually a broadcasted delegate from the engine that you hook into in most of your blueprints. Same with tick. That would be another place where it's broadcasting the tick event. And there are several others. So the first thing to understand is asynchronous versus synchronous. Synchronous is the way you think about code logic by default, right? Which is I have a series of lines, and those lines are executed in sequence, one after the other. And so I have high degree of predictability when I'm doing my logic on line 2 that I have the result of line 1. And so there might be an if block that skips a couple of steps, but when I get to line 5, I know that if the if block had occurred, 3 and 4 were executed. So I know that 1, 2, and then potentially 3 and 4 have occurred by the time I get to line 5. If on line 5 I call out to a function, I'm expecting that function to complete synchronously and then return back before executing line 6. So if I take a chunk of code at line 5, go put it into a function, that function is still going to be processed synchronously, and then I'll process line 6. In comparison, an asynchronous code block introduces a great deal of inconsistency as far as timing, and it needs to be accounted for as you code. So in asynchronous mode, when you trigger line 1, you ask the system to go do something asynchronously. It fires that off and then continues immediately on to line 2. So it doesn't wait for that asynchronous processing to complete before moving on to line 2. Same thing for line 2. If I ask that to do something asynchronously, it will immediately follow on to line 3. And so depending on the duration of those 3 asynchronous calls on lines 1, 2, and 5, I just hypothetically said, let's say the first one takes 10 milliseconds, the second one takes 30 milliseconds, and then the third one takes 5 milliseconds. Your callback functions will come back in a inconsistent pattern, right? So because the line 5 only took 5 milliseconds, it's likely the first callback function to occur. Then the 10 millisecond function completes, and we get the callback at point B, the callback 1. And then finally, 30 milliseconds have passed, and callback 2 gets called. So in an asynchronous mode, the benefit is you're not holding the game hostage to perform these long-running activities, right? So if I ran a 30 millisecond job synchronously, I'd get hitching, I'd get drops in frame rates. The game would basically freeze for 30 milliseconds while that code is being executed. So the use of asynchronous tasks allow the game loop to continue updating frames and allowing your character to do things while the system is processing your request off the game thread. The downside, of course, is the inconsistency in the way that those things occur, and that you need to code in such a way that you realize that your callbacks may come at different times, and it's not as straightforward as running through a block of code synchronously when you're dealing with an asynchronous set of logic. So there are multiple methods that you can use inside the C++ to set up these asynchronous functions. The first is using the Unreal macros. So Unreal provides a variety of macros to declare delegates. They tend to be declared with one parameter, 2, 3, 4, or 5. There are lots. If you just Google declare multicast delegate or declare delegate, you'll get lots of examples online of the signatures that you need to do to define that macro. But recognize that that's just a macro that they provide to simplify setting up delegates. We're not going to spend a lot of time in the C++ code. Again, you can Google the exact syntax if needed. The other is sort of a raw callback function address. So in my second example here, when we use the APIs and we do an HTTP request, we don't wait for that HTTP request to go to the server to fetch the data out of the database and come back. We don't hold the processing up for that. Instead, we pass it this function, this onGet customer character data response receive function, and the HTTP asynchronous function will call that callback when it's completed. And so there's another example of where you might use sort of an asynchronous delegate callback structure. And then the third one is out of the asset manager, where in the asset manager, they have a streamable delegate, which is just a wrapper function that allows you to pass in your function address. And then once the assets have completed their load, so if you're loading a list of assets, once all those assets are complete, the delegate function will fire and you'll be able to continue on with your processing. Now, the good news is that while there are lots of examples in C++ to do this asynchronous processing, there are actually some in Blueprint as well. So there are a number of ready-made asynchronous nodes that you can quickly identify by the execution pins, right? So anytime you have anything, typically if it says wait, other than the delay node, which is a little bit different, most of these will have an outbound synchronous pin, usually at the top. That's basically input comes in, it fires off the asynchronous function and then continues down that synchronous pin line. Once the asynchronous function completes, the subsequent pin is fired and you're able to continue processing. So there are lots of ready-made asynchronous calls that have a callback point for your blueprint, like this ready-made one. But you can also create your own with the event dispatcher. And the event dispatcher is a piece of the blueprint logic that not a lot of people lean on. We are very common with doing functions, doing a bunch of stuff in the graph, adding a bunch of variables. But the event dispatchers is another useful area where you can bind certain activities and certain events to different situations that you have in your code. So with that as an overview, we're going to jump into a very simple example in the editor and hopefully make this come to life. Okay, we're in the editor. And to sort of demonstrate some use cases of how you might use this in blueprints, I've gone ahead and set up two actors. I have my B testing actor, which is this actor right here. And as you can see, I have an overlap box around that actor. And then I have other actor over here, which is just another actor. It's this one right here. So if we look at our B testing actor, there's a couple things we've set up. So on begin play, we use the set timer by event function. And what we're basically saying is looping every 5 seconds, go ahead and call this delegate. So this delegate is a function. We pass its address into this set timer by event function, which will loop every 5 seconds and trigger this particular event. So every 5 seconds, we should see a message that says delegate by event call. We also set a timer by function name. So this one, we're matching the function name with this function name. So we're not actually using the address, this output pin here. Instead, we're using another method of just saying, this is the function name I want to use, loop it every 6 seconds. Then we have a delegate on overlap. And what we're using is a bind event on actor begin overlap. So if you remember, we have this box that will be in the world. We're binding this particular event to any time an actor overlaps with that. So in this case, we'll take the other actor, we'll make sure it's valid, and we'll basically print a delegate overlap. And we've clamped this for every 0.2 seconds so we don't just spam constant overlap messages. And then the last one, and this one is probably the least frequently known about and used, but it's down here, this event dispatchers. A lot of people will create functions and variables, but never really touch the event dispatcher. So we went ahead and hit the plus sign to create this new event dispatcher, which is this function right here. You see it's grayed out. There's nothing you attach to this function. There's no code you put inside this function. But you can set up some parameters. So you can either copy your signature from an existing dispatcher, or you create your own parameters. So we just had the plus, we created the parameter, called it sample parameter, which is a Boolean. And so we defined this event dispatcher inside this blueprint. When we do that, we can now access this bind event to test event dispatcher. So test event dispatcher is here. So we can do a bind event. There it is. Here's the bind and the unbind to the test event dispatcher, which is this event dispatcher here. So we created another custom function. And when you do these, if you have parameters, don't do a custom function like this. Instead, pull off the event tag and add a custom event like this, and it will automatically give you the appropriate parameters to make sure your signatures match between your bind and your custom event. So we take those away. On this case, oops, rebind those. So now whenever the test event dispatcher fires, because of this binding, this code will run and will tell us that we fired off the event dispatcher, and we'll either pass the true or false flag. So to make that work, on event tick, we're basically just getting some random values. And if we're less than 25, this is so we don't just spam the thing constantly. We'll actually do the call event dispatcher with either true or false. So the event tick is ticking. Every time the random integer comes in less than 25, we'll actually fire this off, and we'll flip between calling it with true or false, so back and forth. You can also set up in our other actor. So in our other actor, on begin play, we just pause for 5 seconds just to make sure actors are all loaded. We get the testing actor from the world, and then inside of the other actor, we are also binding to the test event dispatch. So whenever test event dispatch fires, the other actor will hear that dispatch as well. So both the testing event is listening to it. Here's where it's being called. Here's where it's being listened to. and it's also being listened to in the other actor. So if we jump in and actually play, you'll see on screen, once we're up and running, you see the event dispatcher is being called, true and false, true and false. So the event dispatching, the ticking is already occurring. The delegates are firing. And if I filter out these warnings, you'll see that the true and false are happening. I probably should have named these differently. Let's go do the overlap. So you see the overlap happening. So the overlap was by these logs. So when I get close to the logs, you'll see the overlap delegate fire. There's the overlap. The overlap. Rarely use pause. So we've got the overlap, delegate on overlap, fired each time I walked in and out of the overlap. I guess I didn't name those very well. The delegate by event is called, the delegate by name is called. So those are the two that I typed in, the one by event, one by name. And then the event dispatcher, true and false. And then the other one to know is that the other actor that was listening, oops, I said other. Did I not? I don't think I saved it into the world. I did not save it into the other actor, which the reason it wasn't firing is it's not even in the world. We can do that with a breakpoint. Save that app this time. And there's the other actor responding to the event dispatch. And responding again, and responding again. So let's take that off of breakpoint. And then we'll go back to our code. So if you think about some of these delegates, obviously we've set up our timer function here, our timer function by name. We bound to the on actor begin overlap, and we created our own event dispatcher using the event dispatchers here in the blueprint. But there are many other nodes that you use on a regular basis that are, in fact, basically callbacks or delegates, right? So anytime you're using a delay node, basically anytime you're seeing this clock symbol, that's an indicator that you're going to be running asynchronously. So is that right? Is asynchronously? Yes, asynchronously. So this one is not asynchronous. That's a delay. You're right. So here, the wait gameplay for actor, if you were to think about this, if you were coming in with execution into this pin, it will continue on this pin synchronously. So this line gets executed immediately. This line is the callback. So it waits until this occurs. When that occurs, this line becomes the callback. Same with wait for experience ready. Straight through synchronously through those two pins, this is the callback pin. When gameplay effect applied to actor, again, synchronously through those pins, this is the callback pin. So each of these functions that Epic exposes are also sort of asynchronous calls with a callback or a delegate that you can define. And in fact, many of the on begin play, let's go with end play since I have begin play. These are being triggered by the game loop and calling your actors based on the same logic that we just talked about. So hopefully that helps explain a little bit about how you can do sort of more event-based logic using delegates or callbacks, triggering code asynchronously, and then using the event dispatchers in the blueprint nodes.